Hi, this is the third instructional video in the Explain section. We are going to talk about science equipment. And if you take a look, the link will go right here when we're finished with this video. And if you need the electronic copy of the notes, there it is. But you should be getting a hard copy and do this paper pencil. So what I'm going to ask you to do is I'm going to ask you to watch the video all the way through once, get the whole idea of everything, and then you're going to make sure you get your notes page and you're going to fill out the notes page, okay, when you watch it the second time. And then you're going to take this handout and your notes, and you're going to take it to the teacher and she's going to sign it. Okay, so let's talk about science equipment. Okay. In past years, I've found that students don't really know a lot of the equipment because they haven't used it before. So one of my goals this year is to expose you to the different pieces of equipment and to actually use them, so that when you get into high school and they assume you know how to use these things and you know what they are, you're ready to rock and roll. All right, so let's talk about this. You're going to learn about the science equipment we may use in class. I think I have everything in this class, in our classroom, that we're going to talk about, and then some. All right, so you all know that this is a beaker. Okay, it's wide mouth. We use it to transport liquids, to heat things, and to store substances. That's the primary use. We don't use this when we want to measure something really precise, because if you look, so if we go from 0 to 50, that means that line is 25. And then, like, if I want to get 10 milliliters of something, this would not be the tool to use because I cannot get it accurate. When we're talking chemistry, accuracy, precision of amounts is important. You will have different kind of reactions when you have different amounts of things. Okay. All right, so beaker can be used to measure liquid volume only if the measurements don't need to be precise. So if I'm looking for 50 milliliters, 25 milliliters, that's when we can use this. Can. I still wouldn't if I'm looking for precision, okay? You're always going to read it from eye level. I don't want to look down at something. I always want to bend down and look at eye level, okay? Liquid volume is measured in milliliters, small m, capital L, okay? Notice that there's two scales on here. This always confuses people. You're going to use the one that is 0 at the bottom, because we fill from the bottom to the top. So if I'm measuring this amount is 200 milliliters, not 0. Okay, we're always going to use the one on the right. Okay. All right, so this information is important to understand. Milliliters is how we measure the volume of liquid. You always get down at eye level. And we only use the beakers if we don't need super accurate measurements. Okay. All right. Our beakers are glass. Graduated cylinders. Ours don't look quite like this, and most of ours are plastic. I wish they were glass, but we do have plastic. These are what are used when we want to have very precise measurements. And different graduated cylinders have different measurements on the side, and it can be tricky to figure out how it is graduated, what those measurements are. And when I get back, we'll do a quick lesson on that. So the first thing you have to do when you get a graduated cylinder is decide what each line means. Okay. And we're using a graduated cylinder for the purpose of accuracy and precision. So it's important to know how these little lines in between the 50 and the 40 are divided. Sometimes it's 0.1, sometimes it's 0.2, sometimes it's 0.5. We have to figure that out, and I'll teach you a way to do that. You always bend down. You keep it on a flat surface, and you bend down so that you're eye level. Okay, and you read the bottom of a meniscus. Most students have heard that word. A meniscus, when we have liquids in tubes or in glass, it's not straight across. It actually bends, and it starts to kind of go up the sides of the glass. So you don't measure where this meets the glass. You measure the bottom of the little U, okay? The bottom of the dip. And we will practice that, okay? And again, liquids are measured in milliliters, small m, capital L, okay? You need to know all this for a test. All right, this is called an Erlenmeyer flask. We do have these. We don't generally use them very often, but I like to have a few in class because I think they're funky looking. It is a narrow-mouthed container, and it's used to transport, heat, or store chemicals. Often, we put a stopper on the top of it. I don't have enough for every group to have one, so we don't generally use these, but I do have them so we can see them and be exposed to them. I like them because of their shape. All right, a test tube. We all know what a test tube is, right? It is a clear cylindrical glass tube that has an opening and it's round at the bottom. These are used in a laboratory and for experimentation. So usually if we're looking at small quantity of things, we will actually perform the experiment inside a test tube because they're glass. We can see and observe what happens. I think I might have a few plastic ones, but most of them are glass and they do break easily. So we do have to be careful. Tongs. So I have two different kinds of tongs. The top one over here, that's for a test tube. Okay, I do have those. And this one down here, see how it's plastic coated? That is for a beaker. And when we heat things up, glass, and you're need to move it from place to place. You can't pick it up with your hands. In science labs, we don't generally use pot holders like you do in a kitchen. But in a kitchen, you would use a pot holder to move something that's hot from place to place. In a science lab, we don't use those because oftentimes these test tubes are too small to get a good grip with a pot holder. So we use these holders here. And I have some and we'll show you and you'll be able to test them out, okay? And I have some of these. They have plastic on them and that's so that it grips the beaker. Because they're usually bigger mouths, openings, and it's just easier to have some friction to hold those beakers in place, okay? So we got tongs, pretty cool. Eyedroppers, most of us know what eyedroppers are. They're made of glass, and they are used to dispense the smallest amount. If you look at these eyedroppers, I picked it on purpose because you can see that this is 25 milliliters from this line all the way down. So that means there should not be any air bubbles in here, and I'll show you how to get those out. We also have something called a pipette, which I've neglected to put a picture on. We have plastic pipettes, and those are also used to get very small amounts of liquid out. Okay, remember, precision is important because the amount of chemicals you put together will affect the outcome, the reaction that happens. Okay, eyedropper. Goggles, we know what goggles are, right? They are used to protect your eyes from flying objects and chemicals. And if we have to use goggles, you have to keep them on the whole time until your table group puts away and cleans up, okay? If you take them off, there will be consequences, okay? Remember, safety is the key. We're not going to do labs unless I can guarantee your safety. Triple beam balance. Usually Mrs. Linzer has you use this, so I'm going to assume that you have used this before. This is a device that measures the mass, not the weight, mass of an object. And we measure mass in grams, a small g. Okay, we will practice with this. Just a friendly reminder, the middle arm measures hundreds. So each time you move this, it's 100. Each time you move this, I want to say it's 10, maybe. I can't see it. And these are by ones. Okay. We will practice how to measure these because when you get into high school, you have to be pretty fluent in this. Okay. So we'll practice that. This is new probably for you. This is called a ring clamp. If you take a look, there are two different ones. This one would hold a round object, and this one is actually used for different purposes, but generally speaking, we will put something on top of this to heat like below it, we would put a Bunsen burner, we would put this, and then we'd put maybe a screen on top of it, and then set a beaker on it and adjust the height of this. We'll talk about this. We don't use these very often, hardly at all in class, but I think it's important you see that, and I will make sure that I demonstrate that for you. Here's the ring stand. So if you look, let's go back. Here's the ring clamp. So what we do is, this is called a ring stand. We put a Bunsen burner down here. We would put the ring stand here, and we have the ability to put it up or down. And then since it's round, we can put some kind of surface over top of it, usually a mesh, a wire mesh, and then we could put a beaker on top of it to heat it. That's kind of how they're used. This is used to hold a variety of lab equipment, especially during a reaction in which a heat source is being used. So you're going to use this a lot in high school chemistry. Okay, so I want to make sure I expose you and I demonstrate that for you. A funnel. Most of us know what a funnel is because we've used it in our life. I have those. It's to pour liquids into containers with small openings. Or, you didn't know this, what we can do is we can put filter paper in that, and that helps us collect something that might be floating in water. And then we can look at, observe, or measure it or mass it. So that is a funnel. Lab coat or apron, we all know what those are. I do have some aprons. They are not white, they are plastic, and that would protect our clothes from hazardous chemicals. We don't use those very often. Okay, so in this lesson, you learned about some of the equipment. There will be more equipment probably that I get out and show you that's not on here. But you're responsible for knowing this equipment for a test. Okay, so you've watched this through once, kind of got the gist of everything, kind of listened for everything, and then you went through and watched it a second time and you answered you created your notes. So now you're going to take your notes and the safety handout to the teacher and get it signed. You are not going to throw your notes away. You're going to put it in your folder, because anything in this video is fair game on a test. Yes, there will be a test. So you're now going to, when the teacher gives you permission, you're going to move to the practice activities for the science safety, science symbols, and science equipment. If the teacher's not ready for you to move on to the next section, then my expectation is that you read your own book, you read a book from my science literature section, or you go to the website and you click on early finishers and you pick one of those things to do. Okay? All right.